Welcome back to part 4 of the review. Let's get started. Okay, in this problem the only thing you need to do is factor out the greatest common factor. So look at the coefficients first, 4, 20, and 32, and you see that 4 goes into all of them. So the greatest common factor there for the coefficients will be 4. And then we see t to the 7th, t to the 6th, and t to the 5. You can factor out the lowest degree, so t to the 5th we can factor out. And so what's left? We then divide all of the terms by 4t to the 5th, and we get for the first term t, and then you subtract the exponents and you're left with t squared minus, and then when you divide this by 4t to the 5th, you have 4t plus, and then this one, see the t to the 5ths cancel, so you're left with 8. And so that is it for factoring out the greatest common factor. Here we have a trinomial, no perfect squares involved, no coefficient in front of the lead term, and we are told to factor the trinomial. Notice there's no equal sign, so there's no equation to solve. So we're going to simply use reverse FOIL. Come over here and draw our chart, and we need two numbers that multiply to give us 24 and add to give us negative 10. So that would be negative 6 and negative 4. So then we just come over here and write s minus 6 times s minus 4. And we're done. Okay, we're to factor j cubed plus k cubed, and that is a sum of cubes. So you need to know your formula that j cubed plus k cubed equals, and then here's how I remember it. You're going to have a j and a k, then you're going to have a j squared, a j k, and a k squared. That doesn't look very good, so let me rewrite that. So now your job is to figure out what goes in each place, pluses or minuses. Before the last term will always be a plus sign, so you can write that. And then the others will have one plus and one minus. You just need to know which order it's in. So if this is plus, this is plus. The plus, whatever is here, goes first. So we write a plus here, so that means we write our minus there. And we're done. That's all there is to it. Okay, factor this polynomial completely, and it has 12m squared minus 75. Well, the only thing we know what to do with a binomial like this is if it's a difference of squares, and 12 and 75 are not perfect squares. However, they have a common factor, and that factor is 3. So if we pull out the 3 and rewrite it, we will have 4m squared. That looks hopeful because 4 is a perfect square minus 25. And there we have a difference of squares because 25 is 5 squared and 4m squared is 2m, all of that squared. So we have that difference of squares. So we simply add them and subtract them. That's the formula. We take 2m plus 5 and 2m minus 5. Because the formula for the difference of squares is if you have two perfect squares that are subtracted, that's going to be adding the square, or the bases a plus b and then subtracting the bases, a minus b. So that's the formula that you need to use for factoring perfect squares. In this case, we have 9a squared and 169b squared, and we know it's a difference of squares if you've done what I told you, which is to go up to at least 15 or 16 to know your perfect squares. So in this case, 169, the square root of that is 13. So you have 13 squared there. 13b, all of that squared. And of course, for your first term, you just have 3a squared. So there's your difference of squares. And so once again, you add them. And then you subtract them. And so let's FOIL that so that you can see that's correct. We FOIL it by multiplying the first terms, then the outer terms, then the inner terms, and then the last terms. And you can see that the inner two terms here, negative 39ab plus 39ab, cancel, and you're left with 9a squared minus 169b squared, which is what you started with. This one is the same kind of problem, except it's much easier, and the reason is it's not a difference of squares, it's a sum of squares, so it's prime. So this is already as factored as you can get it, and it's called prime. Okay, and here we have an equation again. It says solve. So we're going to factor and then solve. So this is not a perfect square trinomial, and it has a lead coefficient that is not 1, so we will use grouping. We come over here and we say 3 times negative 7 is negative 21, and then our middle term is negative 4. So we need two numbers that multiply to give negative 21, that means a negative and a positive, and add to give negative 4, so that means the larger number is negative. Well, we know that 7 times 3 is 21, so let's try negative 7 and 3, and they do add to be negative 4, so we found it on the first try. Now in grouping, remember, we bring down the first term, then we write our numbers instead of the middle term, and we try to put the positive at the end, so we're going to use the negative first, so that would be minus 7a plus 3a, and then we bring down the last term. Now we group. So in the first case, the only factor we can pull out is an a. And once we pull that out, we are left with 3a minus 7. And in the second case, we don't have anything to pull out, so we will just put a 1 there, and we have 3a minus 7. So as we'd hoped, these binomials are the same, and we can pull them out in front. So we have 3a minus 7, and what is left is a plus 1. In this problem, the length of a small painting is 2 centimeters greater than its width. The area is 168 centimeters squared, so find the dimensions of the painting. And for this, you need to know that the area equals the length times the width. So let's draw the painting. And we don't know the length or the width, so let's draw a width here. We do know that the length is the width plus 2. And then we know that the area is 168. So let's plug in to our formula here that area is 168, length is W plus 2, and width is W. So we rewrite this as 168 equals W plus 2 times W. And then we distribute the W, so we have 168 equals W squared plus 2W. Now let's just shift sides so that we get our W squared term on the left, which is what we're more used to. And then we're going to subtract 168 from both sides so that we can make our equation equal to 0. And so here we have a trinomial that we can factor to find out what W is. So we have not a perfect square trinomial, and we have a leading coefficient of 1. So all we have to do is find two terms that multiply to give 168 or negative 168 and add to give 2. When dealing with big numbers like 168, it's a good idea to factor it and then try different combinations of factors. So I'm going to create a factoring tree. Okay, so one of the factors I see is 4. You could use 2, but I'll use 4, and I get 4 times 42 is 168. 42 is 6 times 7, and 4 is 2 times 2, and 6 is 2 times 3. So 168 is 2 times 2 times 2 times 3 times 7. Okay, we need numbers that are pretty close to the same magnitude because they're going to add to be 2. So let's take that, a combination of 2's. We'll say 4, and let's put the 4 next to the 7, and then we're left with 2 times 3. And this gives us 28 plus 6, or actually it's going to be minus. So that's way far apart. So let's try for a smaller first number. So instead of 4 times 7, let's do 4 times 3, and we get 12. And so here's our 4, and here's our 3, or I'll do it this way. And that leaves 2 times 7, and that does give us a difference of negative 2 in this case. So our numbers are going to be 12 and 14. Okay, and which one's going to be positive? Since they multiply to be a negative number but add to be a positive number, the larger one's going to be positive, 14, and the smaller one's going to be negative. So we come over here and write W plus 14, W minus 12 equals 0. And that means that W plus 14 equals 0, or W minus 12 equals 0. So when you solve, you get W equals negative 14, or W equals 12. Well, how can you have two solutions when you have one width? And the answer is your width is a physical distance, so it has to be positive, and that means you disregard the negative solution, so your width is 12. But we're not done. We still have to find the length, and the length equals the width plus 2 So the length equals 14. And those are your two dimensions. And you want to check that out. And we've already shown that 12 times, well, let's look at this area formula. We're saying that area equals length times width. What is 12 times 14? It's 168. So it checks. Here we have the classic ladder problem. So we have a wall and we have a ladder leaning against it. And what we know about this ladder is that the distance from the bottom of the building to the ladder is 4 feet less than the length of the ladder. So let's call L the length, and the distance down here is 4 feet less than L. So what is this distance here? How high up is the top of the ladder? Well, we're told that it is the length of the ladder minus 2. So we are going to use the Pythagorean Theorem, which says if you have a right triangle, a squared plus b squared equals c squared. So in this case, we have a is L minus 4. So that's squared, plus b, which is L minus 2 squared, equals c, which is L squared. Okay, what is L minus 4 squared? You can use FOIL on that. So we have L minus 4 times L minus 4, and that's going to equal L squared minus 4L minus 4L plus 16, which is equal to L squared minus 8L plus 16. And then we have L minus 2 squared, which is L minus 2 times L minus 2. And using FOIL again, we see that that is L squared minus 2L minus 2L plus 4, which is L squared minus 4L plus 4. Okay. So going back to our formula, a squared plus b squared equals c squared. Here's our L minus 4 squared, so let's write that down. We have L squared minus 8L plus 16. And here's our L minus 2 squared. We have L squared minus 4L plus 4. And that's going to equal L squared. So now let's combine all of our left-hand terms, and we have L squared minus 8L plus 16 plus L squared minus 4L plus 4, and that's going to equal L squared. So let's combine like terms. L squared plus L squared is 2L squared. Minus 8L minus 4L is minus 12L. And let's cross out what we've used. So what's left? What's left is 16 plus 4 is 20. Equals L squared, and we want something equal to 0, so we're going to subtract L squared from both sides. And so that gives us L squared minus 12L plus 20 equals 0. So if we can factor this and use our zero factor property, we can find out what the length is. Okay, it's not perfect square, and there's a lead coefficient of 1, so we can use reverse FOIL. We want two numbers that multiply to give us positive 20 and add to give us negative 12, so that's going to be negative 10 and negative 2. So we come back over here and simply write L minus 10, L minus 2 equals 0. So we solve L minus 10 equals 0, and we get L equals 10. And then we solve L minus 2 equals 0, so we get L equals 2. Well, which one is it? They're both positive numbers, so they could both be distances, but let's look at our original problem again, which is over here. L minus 2 is the height. If L equals 2, that means the height is 0. So that's not true. We can disregard that, and that leaves that the L, the length of the ladder, is 10. But that's not our answer. We need to pay attention to what the question is asking for, and it's asking how high up the side of the building is the top of the ladder. And so that distance is L minus 2. So we take our length, 10, and subtract 2, and we get 8. And so 8 feet is the correct answer. That is the end of the review for Exam 2. Please send me any questions you have. After you take your first attempt at it, if you're not satisfied, practice using the study plan and also let me know, and I'll be happy to create a video review based on your first attempt. Good luck.